Let's return to the equation x double prime equals negative k over m times x. Now there's a standard technique we can use to solve equations of this form, but we're not going to worry about that at this point. We're just going to understand what it means for a function to be a solution of the equation. So we want to verify that the function x of t indicated here, b times the cosine of square root of k over mt, and c times the sine of the same inner function, is a solution to this equation. So in order to verify this, let's just go ahead and evaluate x double prime. Now first we have to evaluate x prime. We take our derivatives one at a time. X prime of t equals what? Well, the derivative of the cosine of t would be negative the sine of t. So we're going to get a negative of the sine function. And as we know from the chain rule, that's going to be a sine of the square root of k over m times t. But we also get the derivative of this inner function. This is a chain of functions. The inner function is square root of k over mt, and then we're taking the cosine of that, so we have to have the derivative of this function, which is just the square root of k over m. And then we're going to multiply that by b. And over here, the derivative of the sine of the square root of k over mt is going to be plus square root of k over m times c cosine of the square root of k over m times t. Taking another derivative, we're going to have to apply the chain rule again. The derivative of the sine function is the cosine, so we're going to end up with a negative cosine of the square root of k over m t, and that's going to be multiplied by square root of k over m times b. And here we're going to end up with another factor. Let's back up. Okay, when we took this derivative, we got the factor square root of k over m, but there's another factor square root of k over m that comes out of the chain rule when we take this derivative. So we get square root of k over m quantity squared. Okay, now over here, taking the derivative cosine square root of k over mt, we get the square root of k over m times the negative sine of square root of k over mt. So rather than putting it out front, let's just be really explicit when we do this. We have the square root of k over m times c times square root of k over m times negative sine of square root of k over m t. And this becomes equal to k over m, negative k over m times b cosine of the square root of k over m t plus c sine of the square root of k over m t